Exploring the Solar System Part 3, Telescopes. We'll be very briefly thinking about 400 years of telescopes, what was first seen when we look out into the solar system, and what we see when we use telescopes today, and again, what's coming up in the near future. So 400 years of telescopes. Galileo wasn't necessarily the first to use a telescope and point it at the sky, but he was probably the first to actually record what it was he saw and start the idea of, well, actually telescopes can tell us far more about what's out there than we can possibly gather just using our eyes. And that was 400 or so years ago, and telescopes have come a long way since then. One option is to use mirrors rather than use lenses in this particular design. And of course, in the last century or two, we've got lots of much bigger telescopes. Instead of using a lens or mirror a few centimeters in size to collect the light, it wasn't long before we were building telescopes with meter-sized mirrors. This one is the Hooker telescope, 100-inch. By tradition, a lot of telescopes are defined by their diameter of their mirrors in inches, but if you prefer, a 2.5-meter mirror in the case of the Hooker telescope, and the 5-meter mirror in the case of the Hale telescope sitting in California. That one is in there because it's one of my favorite telescopes. It was the largest telescope in the world when I was born, and it was the largest telescope in the world for most of my childhood and probably half my adult life. But of course, more recently, we've got bigger telescopes, or not necessarily bigger, but better telescopes, you could argue, for instance, the Hubble Space Telescope and the James Webb Space Telescope. They don't necessarily have larger mirrors, but being above the Earth's atmosphere means that they're not subject to the same aberrations, the same turbulence of the images, and therefore we get sharper images, even though the size of the Hubble Space Telescope mirror is no bigger than the mirror in the Hooker telescope from 100 or so years ago. But there are absolute monster telescopes coming online in the very near future. For instance, the European Extremely Large Telescope is only a few years away now, and that has a staggering 40-meter diameter mirror. So let's have a think about what Galileo actually saw. Our own eyes show us 4 stars which wander around Jupiter, as does the moon around the Earth. This was, of course, a great revelation, because up to this point it was assumed that objects go around the Earth, because when you look into the sky, everything seems to rotate about the Earth. But observing the fact that some objects seem to rotate about, in this case, Jupiter, which is not the Earth, that sort of means that Earth cannot be the center of the universe. So this was a rather important concept, a relatively simple observation. Just look at these dots of light. It doesn't really matter what they are objects that are rotating around Jupiter, and Galileo made meticulous records of how these objects move, showing that they were rotating around Jupiter, showing that the Earth cannot be the center of the universe if some objects choose to rotate around Jupiter. So that was a landmark set of observations carried out 400 years ago. When it comes to looking at another planet like Saturn, there was a great deal of confusion. Galileo's first view of Saturn, well, he wasn't quite sure what he was looking at. Perhaps 3 round stars, the middle one considerably larger than the others. It's clear that telescopes of 400 years ago did not have the same optical quality of the sort of telescopes that we can make today, so it's no surprise that it was very difficult to figure out what it was that you're actually looking at. So Galileo's drawing of 1610 was followed decades later by lots of other people trying to sketch out what they thought they were looking at when they looked at Saturn. All sorts of things. Has it got ears? Has it got a couple of moons on either side? Has it got, well, all sorts of shapes? But it didn't take that long before somebody figured out, well, actually, I think what we're looking at is something like that. It looks like a spherical object with a ring around it. And that was Huygens in 1659. And it's amazing how close that drawing is to a current view of Saturn. We all are familiar now with that view, but at the time, it was very confusing as to what we were actually looking at, mainly because of the limitation of telescopes at the time. Relatively small pieces of glass to actually produce the images, and relatively low quality glass, not producing perfect diffraction limited images. In the case of looking at Mars, Mars presents a rather small disk in the sky, even with high magnification, and so a lot of people were looking at Mars trying to work out what the surface features on Mars were. And Giovanni Schiaparelli produced a rather nice notebook, not only handwritten, but notes the bits and pieces of paper that seemed to be held in place by half a stamp. He was determined to make sure that he didn't spend too much money on putting his notebook together. But he drew Mars, and you can see sketches, and sometimes he drew more detail in the sketches, and he was trying to figure out what these surface features of Mars were. He described them as canali, which means channels, but unfortunately canali got mistranslated as canals. So a lot of maps were produced showing these straight lines all over the surface of Mars. This was in the late 1880s when Schiaparelli first put this together, but because of this mistranslation, it was assumed that what people were actually seeing were canals on Mars. And Percival Lowell in the 1890s, the American, picked up on this and started saying, well, clearly if they're canals, they're artificial, and clearly they are irrigation systems. They are taking water from the ice caps and taking that water to the equatorial regions. And we can see changes on the surface of Mars, which presumably are vegetation growing, and clearly these are the result of an alien civilization producing these canals. It's debatable as to what was actually being seen, but we believe those canals are totally fictitious. But that didn't stop Lowell basically saying, well, it's clear that we have civilization out there. There can be no doubt that living beings inhabit our neighbor world. And this was Percival Lowell recognized as the greatest authority on the subject, or at least greatest authority according to the New York Times. And plenty of people believed him, because a respected astronomer said, we absolutely have proof that there is living civilization on Mars because of these canals. Plenty of people believed him. However, as telescopes got slightly better, it was realized that these things don't actually exist. Lowell was actually using this, a 24-inch refractor in Flagstaff, Arizona. There's an image of him at the business end of the telescope. Part of the problem is, to see Mars, you need a high magnification. You've got the turbulence of the Earth's atmosphere. You've got a lot of light coming in the telescope, but quite often at high magnification, you end up with a tiny beam of light coming out of the eyepiece into your eye. And it's thought that perhaps what people were actually imaging was not actual features on Mars, but perhaps you were imaging the pattern of blood vessels on the back of your eye because of the way the pencil beam of light was actually coming out of the eyepiece onto the back of the eye. And there's also this psychological effect. Once you get told that there are canals on Mars, that's what you tend to see. You have to wait till the Earth's atmosphere is just steady enough to see these things, but if you believe that's what you should be seeing, there's a tendency to see that. So the work of Schiaparelli in the late 1880s, where he was drawing lots of straight lines, it wasn't long before people realized, well, there are features there for sure, but they're sort of straight lines, but not the canals, not the channels that Schiaparelli was talking about. So yes, there are features there. Yes, they're difficult to see, but no, they're not artificial canals. So Antoniadi brought together the idea of what the current thinking was at the end of the 1800s, but basically it wasn't long before we realized that what's actually going on there are changes there, but the changes are effectively changes to the dust levels on Mars, not vegetation, and no sign of any canals on Mars. Amateur astronomy has come a long way, partly because telescopes are so good these days. The quality of the optics in modern amateur telescopes, whether they be using lenses in refractors or whether they be using mirrors in reflectors, and there are some telescopes which use lenses and mirrors, they're so-called catadioptric systems. The quality of these systems are effectively diffraction limited. In other words, the quality is so good they are only limited by the aperture of the lens or the aperture of the mirror. far better than we could possibly expect from centuries past. And some amateurs who've got very deep pockets will buy very large telescopes. There are systems that I can't afford, like this. You get an idea of the size of this system if you put a human next to them. These things weigh about 1/3 of a ton, and they cost some 5-figure sum. But amateurs do buy telescopes of this sort of size, and they produce superb images of the planets as well as other objects in the universe, and can be used to image those with digital photography. But of course, even though that is about as maximum you can expect from any amateur, for research telescopes, the size of the main mirror that's collecting the light has just gone up and up and up. There's the Hooker telescope and the Hale telescope, and to scale, those are various telescopes that are either already existing or shortly to exist. And for scale, there's a tennis court in the bottom left and a basketball court in the bottom right. And if your eyesight is good enough, there is actually a human there to give you scale. So the current largest telescope in the world is Gran Telescopio Canarias. That's hexagonal segments, so it's not strictly speaking a diameter, but roughly speaking, it's got a diameter of about 10 meters or so. That is currently the record holder and has been since about 2007. The telescopes that have gone into space actually have rather smaller areas, so you can see the Hubble telescope and the James Webb telescope are smaller areas, but of course they have to be small simply to get them on top of a rocket and get them up above the Earth's atmosphere, either in orbit around the Earth in the case of Hubble, or at the L2 Lagrange point in the case of the James Webb Space Telescope. But you can also see from this graphic that not only do we have a large telescope existing at the moment, but there are absolute monsters coming online in the not too distant future. The blue one in the top right is the 30-meter telescope, and the green one on the right-hand side there, the ELT, is the extremely large telescope. And you can tell that astronomers are not good at naming things. So the ELT will be coming online in a few years, and that will have a light collecting power that far, far exceeds any of the existing telescopes. So there's the 5-meter Hale telescope, just as an example. What was the largest telescope in the world for most of the last century, but has now been overtaken by mirrors that are about twice as large. But where would you place a telescope like this, apart from putting it inside an observatory? Where would you place that observatory in the world to get the best possible views of either the solar system or the rest of the universe? There are a number of sites around the world, but most people consider 3 sites to be the best in the world. You either choose a volcanic island, like Hawaii, for instance, or the La Palma, Tenerife in the Canary Islands. Volcanic islands have the advantage, they stick out above the ocean and you get very stable air over the top, so you get beautiful seeing conditions, very crisp images from those sites. Alternatively, you go to the Atacama Desert in Chile. Very high desert, so again, you're above a lot of the atmosphere, very dry, not much water absorption. So a lot of the world's best telescopes are centered in those 3 locations. For instance, if you go to the site in Chile, Charapaxón, it's a beautiful place, and there's one example of one telescope sitting on the mountain. There are other mountains in the area that also are populated with telescopes. They are sitting there above a lot of the atmosphere, they're sitting above a lot of the water, they're certainly sitting above the clouds, so you get unobstructed views of the sky. From this sort of location, you can expect to get more than 300 clear nights a year compared to the UK, where you're lucky to get a handful. If that's not good enough for you, sticking a telescope on top of a mountain. If you wish, you can get above even more of the atmosphere if you fly it in the back of a 747. This was done for a while. SOFIA is the stratospheric observatory for infrared astronomy. With infrared, it's particularly important to get above the atmosphere because the atmosphere absorbs infrared light. So at the cruising altitude of a 747, you can get above 90 or 90-something% of the atmosphere, and so the infrared telescope sitting in the back there through that open window allows you to get infrared light in the back flying at high altitude, at more than 10,000 meters or so. Of course, the ultimate way of getting above the atmosphere is not to fly a 747, but to put it in space. So you get the Hubble Space Telescope in Earth orbit, a relatively modest 2.5 meter mirror, but above the Earth's atmosphere gives you exceptionally clear views. And more recently, the James Webb Space Telescope, the large 6-meter diameter mirror, again, hexagonal segments. It had to be folded up, so there was a piece of origami to get it folded up to the point where it would fit inside the fairing of a rocket, and then launched off on Christmas Day 2021. And it's been doing good work for the last 2 or 3 years, exploring the universe in the infrared part of the spectrum. So here's a comparison, for instance, of what we see of Jupiter. Jupiter seen in visible light with the Hubble Space Telescope, and Jupiter seen in infrared light with the Webb Space Telescope. The colors on the left are slightly exaggerated, but close to being natural, because these browns and oranges are the result of various organic molecules of ammonia and some hydrosulfides that are giving them the characteristic colors. And there's the great red spot, this storm system that seems to have been raging for 400 or so years. The James Webb image looks very similar in the sense that we see the same structure, but clearly we see different detail in terms of what is bright and what is dark, and that will depend on which particular infrared wavelength we choose to observe in. Notice there's a little bit of a tinge at the top and the bottom. That's not an aberration of the James Webb Space Telescope. That's actually an aurora that exists on James Webb. Because it has a strong magnetic field, it has aurora, much like the Earth, and so the glowing there is a genuine part of a glow in the Jovian atmosphere. If we look at the Hubble Space Telescope view of Saturn and compare that with the James Webb view of Saturn, we find it looks rather different. Saturn is made mainly of methane, and that absorbs at this particular infrared wavelength, and so we don't see much light from the body of the planet. But at this particular wavelength, the rings, being lots of tiny ice particles, reflect that wavelength very strongly, so the rings look very bright and the body of the planet looks very dark. We get the same sort of thing when we look with the James Webb Space Telescope at the rings of Uranus. The rings themselves are difficult to see in visible light, but they appear very bright in infrared, again, because compared to the body of the planet, the rings are reflecting sunlight compared to the body of the planet, which tends to absorb at infrared wavelengths. It's interesting to note that just on the left-hand side there, we have a very bright spot. It appears to be that there's a storm raging on Uranus at this particular time it was imaged. And this is a reminder that when spacecraft like Voyager, for instance, Voyager 2 going past Uranus back in the 1980s, it only had a few hours there. And when it went past the planet, it saw nothing interesting. It looked essentially blank. Clearly, it's not blank. It just so happened that for the few hours that the spacecraft was visiting, there were no storm systems raging. The advantage of ground-based telescopes, we're nowhere near as close as a spacecraft can get, but we can watch it, in essence, at our leisure, whereas a spacecraft only has a very limited window in which to see what's going on. And in this case, we can revisit the views of Uranus and see if that storm system decides to change in any meaningful way. Similarly, with Neptune, this looks rather odd because we have a ridiculously bright object at the top there and a not so bright Neptune with its ring system in the bottom. And this is initially quite surprising because the bright object at the top is simply one of the moons of Neptune. But the moon seems to be orders of magnitude brighter than the planet, even though in visible light we see a relatively bright Neptune and relatively faint moons. In infrared, it's the opposite way round. Neptune, again, there's an awful lot of methane in Neptune. It's absorbing infrared, so it doesn't look particularly bright. Whereas this particular moon is Triton, and the surface of Triton is basically frozen nitrogen, so it's a very reflective surface, and so that appears very bright. So it's rather odd that one of the moons looks orders of magnitude brighter than the planet itself. So what's coming next in terms of, we've got space telescopes, we've been building up the apertures of telescopes for a long time now. There are new projects that are coming online fairly soon. The LSST, what used to be called the Large Synoptic Survey Telescope, will be coming online very soon. The telescope is called the Simonyi Telescope. It's sitting in the Vera Rubin Observatory in Chile. It has a relatively modest mirror size of 8 meters, by no means the largest in the world. But what separates it out from other telescopes is the size of the camera that's going to be used. The camera and telescope optics in combination will allow it to survey an awful lot of the sky. So it's going to be carrying out a survey for about 10 years or so, and it's going to be mapping out the sky every few nights for the next 10 years. As well as looking out into the universe and finding all sorts of stars and galaxies, it's going to be cataloguing billions of stars and billions of galaxies. But along the way, it's also going to find objects in our solar system, simply because it's going to photograph, effectively map out everything that's out there. It's estimated that this survey will probably end up doubling the number of objects in the solar system. Most of them are going to be quite small, admittedly. They're not going to find many new planets, though indeed it is expected that it will find new planets, as well as lots of asteroids, lots of icy bodies, etc. It's expected that this system will probably end up finding 5 million new objects in the solar system by the time its 10-year lifetime is up. And because it's a survey instrument, it's going to find out what's out there, and then it's going to pass the interesting stuff to the large aperture telescopes, including this one, the European Extremely Large Telescope, with a 40-meter diameter mirror. And again, if you're having trouble with the scale, there's a couple of people there sitting in front of it. So very large aperture telescopes like this are going to take the information from the survey telescope, which is going to find out what's out there, and then big aperture telescopes like this are going to follow up by looking in detail at these new objects that are found in the solar system, as well as these more distant objects in the rest of the universe. So if you want to know what existing telescopes are doing, like the Hubble and the James Webb, and if you want to know what's going to happen when these new telescopes come online, such as the LSST and the ELT, the Extremely Large Telescope, those websites will give you far more information about what they are doing. Thank you all for listening.